Hello everyone. So in this video, we will talk about some of the AMC 8 problems from 2023. So this is the number 9. So I had another video for the first 8 problems. So if you didn't look at that, so you can review that for sure. But this is the first question on this video, which is number 9. So the graph below shows her elevation. She's skiing and above the base of the mountain as she skis along that trail. In total, how many seconds? Okay, so we are gonna find in total how many seconds that she spent at elevation of between 4 and 7 meters. Okay, so you know we are given some numbers on the y-axis, like this is 7, right? And then this is like 4. So what I'm gonna try to kind of draw a line to see that height. So this is the 7, okay, and then this is 4. And question was asking the total time that she spent in between those two height, basically, okay? So the first thing that we see, like it starts with something over 14, then it decreases at some point until 2 seconds, and then after 2 seconds, the height of her elevation of that actually her the place is in between 7 to 4 at this point. So it starts at 2 seconds until 4 seconds. So we have 2 seconds already that is in between this. But after the second 4, like 4 seconds, it is decreasing a bit more and then increasing after. So after 6 seconds, like 2 seconds is lower than 4. So we are gonna have this interval, which is gonna be between 6 and 10 actually, which is basically another 4 seconds. Okay, and then now it's above 7, we don't care, so we just need to find the region that is in between 4 and 7. So we do have 12 to 14 seconds, which is 2 more. So if you combine those, we do have 8 seconds. So that was the answer. So I hope that is kind of clear. So let's see the next problem. So the number 10, Harold made a plum pie to take on a picnic, and he was able to eat 1/4, and then he left the rest for his friends. So mean that he is gonna share 3/4 of that. So I'm gonna start with 3/4. This is the one he left for his friend. And after a moose came by and then ate 1/3 of this. So if you are gonna like kind of lose 1/3 of this, you're gonna have 2/3 of this left, which is 2/3 times 3/4. So which will be 1/2 basically left of the original pie that we start, right? And after that, a porcupine ate 1/3 of what's left over. So which means we are gonna have 2/3 of this leftover will be left. So that will give us 1/3. And at the end, we are actually having 1/3 of the original one. So this is the answer. So you could do this way, which is not too much work. But if you kind of didn't see this one, this approach, you can try it a little bit differently as well. So what else we can try? Since at the end we are looking for some sort of ratio, maybe we can look at the denominators. The largest is 12. So let's say original pie is 12 pieces. Okay. And if you finish the 1/4, so that means the 3 pieces of 12 will be gone. So meaning that we are going to have 12 minus 3, which is 9 left. And after that, this is the number of pieces or like whatever like portion he is left like for his friend. But after like those 9 pieces left, so we are gonna finish 1/3 as well, which is 1/3 of 9 is 3. So 9 minus 3 is gonna be left over now 6. And I would like to find 1/3 of this as well. So 1/3 of 6 is 2. So 6 minus 2 is 4. So this is the final number of pieces that will be left over. And we start with 12, so this is the whatever leftover, so that should be 4 out of 12, which is also 1/3. So again, if you couldn't come up with the first approach, you can always choose a number that is actually easily divisible by the given fraction stuff, and based on that, you can find the ratio as well. So that is choice D. So that is number 10. So let's look at the next one. So number 11, we have a approximation basically. So there's a date right here, but it doesn't like give us anything to do with our problem. So we are trying to find the the traveling takes this much distance, like 292526838 miles, and it took about 6.5 months, right? And which are the following closest to the average speed in miles per hour? So let's highlight those units because we are given that's like month, this is hour, so this is mile, this is also mile. So that is something we have to keep in mind. So the distance is always rate times time based on distribution. In our case, we want to find the rate, which is if you divide both sides by t, so the r will be d over t. So the rate is distance over time. So which is what we are looking, right? So I'm gonna say this is 292.526 and then 838. And then this is divided by 6.5 months. But every month, like as average, like most of the time, we have 30 days, right? So we can just take that 30 instead of like 31 or 29, whatever. So 6.5 months. If I multiply this by 30, I will get a number of days, but I do need number of hours, and every month every day has 24 hours. So now when I multiply that number of days by 24, so that will be my hours, which is gonna be miles per hour, which is good. So this is what we want. But since we are looking for the approximation, we don't really need to deal with these numbers. And also we cannot use a calculator. So this is like 292 million, which is like a huge number. But if I like to kind of approximate this number, so I will say 300 million is one of the best numbers I can actually use to make it approximate value. And that is 6.5, okay, times 30 times 24. So, which is nice. So I can cancel 0 by this one, and I can cancel this 3 by this 3, which will be 10, and 6 more zeros, which is like 10 million. You can write as power of 10, like 10 to the 7th power if you want to, but let's see if we need to do that. So we have 6.5 times 24. So let me write down 10, and then we have 6 more zeros. And if there are too many zeros, maybe it's good to write as power of 10, but for now I'm gonna leave it that way. So if you multiply like 6 by 4, you will get 24. If you multiply 0.5 by 4, you get 2, which is 26, which is approximately 25. The reason I'm telling this because if you have some sort of like 24, I can easily divide 100 by 25 to approximate. So I'm gonna take this 4 as 25 to make a bit better approximation, because like if the numerator has 100, which we do have a lot of hundreds, we may divide by 25 easily. And then if I multiply this by 4, I will get 26, but I'm gonna write that 25 as well. But even though for us to do this one, we should multiply numerator by 4 as well. So that is gonna be 4 times 10 million divided by 25 times 25. So I hope that makes sense. So I multiply this by 4, and then I multiply numerator by 4 as well. So I can get something like close to 25, which is 26, but I just rounded to the 25 to make some approximation. So this number like when I did have this 26, and then this was 24. So I kind of did both numbers are average of those two, which means my approximation is actually a nice approximation, because one of them is getting bigger, the other one is getting smaller. So overall, it doesn't really affect my average too much. Okay, so for this numerator, if I divide the 100 by 25, so I will get 4. Okay, so and then I cancel 2 zeros. Be careful, we have 2 more right here, and then we have 3 more right here, which is 5 zeros. So if you confuse, you can just write it like 4 times 4, and then this is gonna be 400,000, which can be written as 100,000. The reason I split that because I'm going to divide by another 25. So if I divide by 25, so you will get 4, and then this is going to be 1. So 4 is 64, and then you get a 2 more zeros, right? Actually, 3 more zeros, so I need to be careful. So that will be 64,000. So of these choices, this is the closest one, which is actually our answer. And I do feel comfortable with my answer because my rounding wasn't too off. So which is why that is okay. But if you have like time, you can always go ahead and do multiply and divide, which is going to be okay to confirm the answer. But I think this is okay. So you can do this question slightly different ways, but I think this is good. So let's see our next problem. So this is a nice like a circle problem, but it's just asking how to remember the area of the circle. So the area of a circle is pi times radius squared, right? And what we are looking for, the shaded circles, what like fraction of the interior of the large white circle is shaded. So you know this is the largest circle we have, and there are some part of this largest circle is shaded, and we like to find what part of that white circle is shaded. So we do not have any numbers in terms of size or the radius and stuff, but at the end we are looking for the ratio, so which means it doesn't really matter. So you can choose a number to make it less complicated, and then it will give us any correct ratios, okay? So if I choose this radius as like 1, and that means this radius is also 1, and then this radius is also 1. So some of these 3 will be pi times 1 squared. That's the area of one of these, but we have 3 copies of this, so that should be 3 pi. Okay, and what we want to find also is this shaded region and this shaded region, but you know, we do not have any nice formula for this kind of region, but we can do like find the area of this circle and subtract area of this circle and area of this circle. So to do so, I like to find the center of the circle that has shaded parts. So the radius of that is gonna be this distance, but make sure I choose this to be 1, which means 1 unit is 2, right? So which is why this radius will be 4 and this radius will be 2. So the area of this circle, pi times 4 squared. And if I subtract area of this circle plus area of this circle, I will get the shaded region for this piece and this piece. And that would give us pi times 2 squared. And you can double this number because you get 2 of these. Okay, so that should be times 2. And that's 16 pi. And then this is 4 times 2 is 8 pi. So the difference will be 8 pi. So that region is this piece and this piece. So we have 8 pi for these two red region, and then we have small 3 circles which add up to 3 pi. So those regions are actually our shaded part. So 3 pi plus 8 pi is the total shaded region over the area of the largest circle. So if you take this as your center point, so from this point to this corner, there is like 3 units, but every unit was 2. So which is why that's going to be 6 for the radius of the largest circle. So the pi times 6 squared is my area of this white circle. That's 11 pi for numerator, and that is 36 pi. And cancel this, we do get the answer as choice B. You don't have to give this number like radius as 1. You can choose anything. I just choose that to be 1. So whenever you choose like any other numbers, as long as you don't do anything wrong with your calculation, so you should get still the same ratio. Okay, so that was the number 12. So let's move on to the next problem. So we have a bicycle race, and then there are 7 water stations are evenly spaced between the start and the finish lines as given. So, you know, this is 1, this is 2, there are more in between, and then this is 7. And this is the start line, this is the finish line. And there are also two repair stations evenly spaced between the start and the finish line. Okay, so the third water station is located 2 miles after the first repair station. So if you want to add maybe, so water station like number 3, so I'm going to say this is water 3. So you can say this is 4, which you don't really need it, but let's say this is 4, like 5, and this is 6, and then this is 7 already. And we are given there are two repair stations between the start and the finish line. Be careful because we have 1, 2, 3, 4, 5, 6, 7, 8 spaces between the start and the finish line. So if I call the whole distance, let's say this is D, that is what we are looking, by the way. So this is between the start line and the finish line is I'm gonna name it as D, okay? So you can call that 8D if you want, or 8X, because we have 8 equal space, right? But there is a like two repair station that is also evenly spaced between the start and the finish line. So if you divide this whole thing into 3 equal pieces, then each one of these will be D over 3, I guess, units long, right? And we are also told that like the one of those water station, like the third water station, is located, so which is this guy, 2 miles after the first repair station. So if there is like a point right here, so that is gonna be my, I should name this number as the water, like repair station, I would say. So repair station number 1. And then this distance right here in between 3, water station 3 and that repair station is 2 miles. And based on this information, we just like to know the total distance, right? We can just kind of use this information because this was the first repair station, and if you have another one somewhere right here, which we can find it as well. So the distance between the start line and all the way to the first repair station has to be D over 3, because we have only 2 repair station. If you have 2 repair station, you are dividing the whole distance into 3 equal pieces, and the first part is going to be D over 3. So let's keep that in mind. This is equal to this piece, which is D over 8, and plus this space, this is also D over 8. This is D over 8. And then from the water station 2 to 3, that's also D over 8. But we know this is 2 miles. We just need to subtract that to get this piece. So we have D over 8 plus D over 8 plus D over 8 minus 2. So this one is the distance between right here. So maybe I should kind of label a bit differently as well. So this distance right here is this one. So if you solve this equation, then the rest is, I guess, a bit easier. So let's go ahead and do that. So if you add the 3 Ds, that's gonna be D over 3, and then that will be 3D over 8. If you subtract from both sides, maybe I should subtract D over 3 from both sides, but anyway, so 3D over 8 equals -2. If you like multiply this fraction by 8, that will be 8D. Multiply this by 3, which is -9D. 8 minus 9 is -D over 24 equals -2. Multiply both sides by -24, so D is 48. And then we were looking for that distance, so that is our final answer. So again, this is slightly challenging problem. So if you didn't come up with writing this equation, you could just go back to choices and just assume one of those is correct, and based on that, you can just find each part and see if that kind of satisfy those restrictions. Okay, so you could have done that as well, but I'm gonna leave for you to try that part. So here's the next problem. So Nicholas is planning to send a package to his friend and to pay the postage. So he would like to cover the package with a larger number of stamps. Okay, so I don't know the point, but it's okay. So he wants to use large number of stamps. Suppose he has a collection of 5 cent, 10 cent, and 25-cent stamps, and with exactly 20 of each type. And what is the largest number of stamps he could use to make exactly $7.10? Okay, so this is straightforward problem at some point, but at the same time, it's a bit challenging as well. So he wants to use more number of stamps. To do so, he used to use a lot of 5-cent stamps and a lot of 10-cent stamps, and then maybe less number of 25-cent stamps, which is what we are going to try to achieve that optimization, right? But let's use only like all of those 25 cents. So if I have 20 of those 5 cents stamps, that will be just 100 cents, which is $1. Let's use all of those 10 cents as well. So we have 20 of those 10 cents, which is going to be 20 times 10, which is 200 plus that's $2. This is $1. So this is add up to like $3, right? So if he wants to use all of those, his 5-cent stamps and 10-cent stamps, he can only get $3, but he is gonna need $7.10, right? If I subtract 3 from that, so he needs another $4.10. But the problem with this, you cannot really get $4.10 with remaining 25-cent stamps, because 25 you are gonna get some multiple 25. So the $4 is 400 cents. So you do get 400 cents, but you cannot get 410 cents. So which is why we should have, if I have 400, so which is $4, so 400 cents divided by 25, you know, 4 of these is 100. So that means this is going to be 16, because 4 times 4 is 16. And if he is like 16 of 25 cents, he's going to get $4. But if he's using this many 25 cents and then 20 of the other ones, that's 20, 20, and 16, that's 30, like 40, 56. But that will be only $7. But he cannot get that, so he needs to get $7.10, meaning that he has to use more than 16 of those 25-cent stamps. So let's go with 17. If he's using like 17 of those, because our goal is to get less number of 25 cents, if he's using 25 cents like of those, like 17 of those, this number, the total will be 425 cents, which means he's gonna need to decrease this number by 15 cents from the other part. You know, we just subtract $3 from that total to get this number. But if he's using 17 of those 25 cents, then this is gonna be 425. So which means I should decrease this total by 15 cents to get the $7.10 exactly. But if I want to get the 15 lesser, like 15 cents lesser than this number, so I should decrease the number of 5 cents by 1 and number of 10 cents by 1. So which is why we do need 19 of 5 cents and then 19 of 10 cents plus 17 of 25 cents. If you multiply those, you do get 710 cents. So I'm gonna leave it that calculation, but you don't really need to do this calculation, because if you really understand what I said right here in terms of subtracting 15 cents, then you should be all good with that. So we do have 19 of 5 cents, 19 of 10 cents, and 17 of 25 cents. This is like 36. I mean 38. 38 plus 17 is 55, which is nicer because the largest number is possible. So that is the choice here. So that is why I said this question slightly challenging, because it wasn't too simple. And I guess that is it. So let's look at our last problem. So we have someone who walks half mile to get to school. So let's highlight this part. And his road consists of 10 blocks of equal length, and he takes 1 minute to walk each block. Okay, so that is important. And today, after 5 blocks, he discovered that he has to make some changes because there's something going on here. So he's gonna take this longer path, adding adding 2 more blocks, right? And instead of 1 block, he's gonna get 3 blocks instead of 1 block, which means increase that total length by 2 blocks. from the time he starts his detour from this corner, at what speed in miles per hour he must walk so he can get school on his usual time. Okay, so first things first, like we know the distance equals rate times time, which is we've seen a lot already. And we know the distance is 1/2 miles. And we do know that he's gonna take 1 minute for each block, right? And there is a 10 block, so 10 block should be 10 minutes, right? If there is no distraction on the road. So 10 minutes will be 10 block will take 10 minutes. But, you know, we are told miles per hour. So I will say the rate times time. Time has to be in hours, but it is going to take 10 minutes. 10 minutes is 10/60, which is 1/6 hours. Okay, so if you multiply both sides by 6, so you will get 6/2, which is going to be 3 miles. So 3 miles, let's actually continue here. So 3 miles is his rate on the regular day. Okay, so meaning that he has to make this a bit like faster. As you see, the choices are bigger than this value, which makes sense. Okay, so but now he actually take already 5 like minutes because he didn't change his first like speed until he see this like detour, right? Mean that he already used 5 minutes of total 10 minutes. So, and then there is like 1, 2, like 3, 4, 5, like 6 blocks basically. I mean 7 blocks because we had like 5 already passed, and then we add 1, 2, and then 1, 2, 3, 4, 5 was there. So which means there is like total of 7 blocks, meaning that it has to take 7 minutes, right? If he doesn't change his speed. But we do have like now, let's think about the distance for the remaining part. So, you know, 1/2 miles is equal to 10 blocks. So if 10 blocks is 1/2, if you divide by 10, you will get 1/20. 1/20 miles is just 1 block, okay? But he's gonna finish 7 blocks to finish up, so that will be 7 times this one, 7/20 miles that he has to finish. And we are looking for a rate for that distance, and then his time left is still 5 minutes because he already used 5 minutes of his total time until getting this point. So after this point, he still have 5 minutes, which is 5/60 hours, which is 1/12. But our goal is to get the R, so you can multiply this by like 12/1, which is like 1/12, 12/1. So if you multiply this by 12, so I can cancel these. So that should be just R. And you know, I had 12 times 8/20. So you can multiply, but I will divide by 2 first. That is 6, and then this is going to be 10 because 6 times 7 is 42. 42/10 is 4.2, and that is miles per hour. And that is my rate, and then that is this choice speed. So we didn't use any sort of calculator at all. So we kind of use our numbers in a way to cancel those. And I hope that makes sense. Okay. So that was number 15 on the test. I'll see you in the next video.